Good afternoon to you viewers and subscribers, and welcome back to another one of my videos. And in this week's video, I am going to be presenting to you the curing process for your freshly mixed concrete on site. And I'm also going to be demonstrating to you the procedure of how to obtain the compressive strength of your concrete. Now, the compressive strength of your concrete is a very important aspect that forms the quality assurance and the quality control of your concrete. And without you doing the compressive strength of your concrete, you're not going to be able to tell if the concrete that you have used to pour your structures is suitable. So after you have carried out your temperature test, the slump test, and the ear test for your freshly mixed concrete on site, the next important test that must be done is the compressive strength of your concrete. So in this video, I'm going to be delving into that. So make sure to watch the video until the end, and I'm sure that you are going to find the video very interesting. Thank you for watching. Thanks. The compressive strength of concrete. The compressive strength of Portland cement concrete is the ability of the concrete to withstand specific compressive forces. And note that compressive forces are forces that are trying to crush the concrete. So if you look at the picture to the left of the screen, you will observe the concrete specimen that is placed in between the two crushing plates. There's a crushing plate at the top and there is a crushing plate at the bottom. So what the concrete crushing machine essentially does is that when you start to operate the machine will apply a compressive force through the upper plate and the plate at the bottom to the concrete specimen in the middle, and that will tend to try to crush the concrete. So that is essentially what the compressive forces does to the concrete via the concrete crushing machine. It just apply a force at either end of the concrete specimen that will tend to try to crush the concrete. Now, the compressive strength of concrete depends on one, the water-cement ratio, and as I've stated to you before, that the water-cement ratio ranges from 0.4 to 0.6. So what you will want to do is to take an average between 0.4 and 0.6, which will work out to be 0.5, and your water cement ratio supposed to work out to 0.5. So the water cement ratio is whereby which you divide the weight of the water or the amount of water by the cement, and that should work out to be 0.5 ideally. Number 2 on the list is the strength of your cement in the concrete mix. So I can't stress this enough that when you're mixing concrete, you must ensure to have the correct proportion of concrete to the concrete mix. You can't put less concrete, you can't put less cement in the concrete and expect that you're going to get a strong concrete. You must put the right amount of cement in the concrete in order to get the concrete to be strong and to also pass the compressive strength of the concrete specimen. Number 3 on the list is the quality of aggregates used to mix the concrete. Yes, I have stressed to you before and I have demonstrated to you the importance of having the right quality of aggregates to go in your concrete mix. I've demonstrated to you how to do the specific gravity of your fine aggregates and your coarse aggregate, to do the sieve analysis, to do the fineness modulus and all that, because without you doing those tests, you're not going to be able to ensure that the aggregates that you use to do your concrete mix is suitable, and that can have a negative impact on the crushing strength of your concrete. 4 is the quality control during the production of your concrete. So if you're operating a concrete plant you must do regular checks or frequent checks of your aggregates, especially if your aggregate is stored outdoors. So you must always do your wet weight of your concrete. You must also do the moisture content of your aggregate and the wet weight of your aggregate to ensure that you're putting in the right amount of water in your concrete mix design. Also, if you're running a concrete plant, and I'm speaking from experience now, you must on a regular basis or a frequent basis do the quality control checks, and that is your sieve analysis, your specific gravity, and so on. Types of curing mold for concrete specimen. There are two types of curing mold for your concrete specimen. There are the cylinder mold that is primarily used in America, and there is the cube mold that is used under the British system or in Europe. So if you observe the picture to the left of your screen, this is an example of a cube, and the dimension of your cube is 150 millimeter in width, 150 millimeter in height, and 150 millimeter in length. So in terms of the imperial system, 150 millimeter is equivalent to 6 inches. So your cube is basically 6 inches in width, 6 inches in length, and 6 inches in height. And you must also observe that because you're going to need that to calculate the cross-sectional area in the event you have to calculate the compressive strength. The picture to the right of your screen is the cylinder mold, and the cylinder mold is usually 1 foot in height or 12 inches in height and 6 inches or 150 millimeter in diameter. And you must also observe the diameter of the cylinder mold, because you're going to need that to calculate the cross-sectional area of the mold to calculate the compressive strength in the event that the crushing machine does not give you the direct crushing stress. So the cross-sectional area of the cylinder mold, as you can see here now, it is pi d square over 4. And I will get to that a little bit later in the presentation. So the procedure for molding your cylinder and cube concrete specimen. So one, the cylinder mold. So if you're going to use the cylinder mold to prepare for the concrete breakage or the concrete crushing on site, or you're going to transport the concrete specimen to the lab to get it break, you must observe the following. So the cylinder mold, you're going to use a scoop to fill the cylinder with concrete at 1/3 of its height for each layer, and you're going to run each layer 25 times by only penetrating the layer below by 1 inch or 25 millimeter. So just as I've indicated to you when you're doing your slump test or when you're doing your ear test, you basically just fill the mold to about 1/3. The first layer you run 25 times right throughout the cross section of the concrete inside the mold, and then you fill the mold again to 2/3 of its height. You run through the second layer and you only penetrate the first layer by 1 inch. You do the same for the third layer. You put in the third layer, you run 25 times through your third layer, only penetrating the second layer by 1 inch. So that is basically how you prepare the sample or this concrete specimen by molding or by cube, just as when you're doing the slump test or you're doing the air test, the amount of times that you run. 2, make sure to make 4 samples of the concrete cylinder specimen. So when the concrete truck come to the site, you must also ensure to have your 4 molding cylinder ready to be filled with concrete so that you can transport to the lab. 3, take all 4 samples of concrete specimen to the lab and place in a lime bath of water at temperature between 21 degrees Celsius to 25 degrees Celsius or 69.8 degrees Fahrenheit to 77 degrees Fahrenheit for curing for 7-day and 28-day break. So yes, when you have placed your 4 cylinder, when you have put your concrete in your 4 cylinders, you must transport those concrete specimen to the lab, or if you have a lime bath on site, you're going to place those 4 cylinders concrete specimen in the lime bath for curing for the 7-day break and for the 28 days break. And what the lime bath is, they just catch a tub of water and they add calcium carbonate to the water to give it the lime bath effect. So if you observe the picture to the right of your screen, that is an example of how you cure the concrete specimen inside of the lime bath. So 4 or 5, concrete carries an initial setting time of 7 days and a final setting time of 28 days. So within the first 7 days of curing in the lime bath, you are going to transport the 2 concrete cylinder specimen to the lab for crushing or breaking if a temporary breaking lab is not available on site. So pretty much the sites that I've worked on here, it is equipped with a breaking machine on site. So, and we have our lime bath on site. So all we have to do during the 7-day break, we just go to that location and take the first 2 concrete specimen out, and we break those concrete specimen. So you're going to place the concrete cylinder specimen on the concrete breaking machine. The crushing machine will display the load it takes to crush the concrete specimen, and you're going to repeat this procedure for the other concrete cylinder specimen. So note that some crushing machine will give the compressive strength in Newton per millimeter square or PSI. So if the crushing machine does not give you the crushing strength directly, you can calculate the compressive strength of the concrete specimen by dividing the load by the area. So as I was saying to you before, it is quite worthy for you to observe the cross-sectional area of the concrete specimen. So in the event that the crushing machine does not directly give you the compressive strength, you have to calculate. So what the concrete machine does is just give you the load, and then you divide that load by the cross-sectional area of the concrete specimen, and that will equivalent to the crushing strength. So whether you calculate the crushing strength in pounds per square inch or in millimeters, so you must observe the units of the cross-sectional area, and you must make sure that it's consistent with the load. So if the load is in pounds, you're going to divide the cross-sectional area by the amount of square inch, the cross-sectional area by square inch. If the load is given in newtons, you must divide that load by millimeter square. So in the event of the cube was 150 millimeter wide by 150 millimeter length, so it's 150 millimeter times 150 millimeter. Divide that by the amount of newton, and you will get the compressive strength in newtons per millimeter square. Now, to the procedure for breaking the cylinder. So one, you're going to take an average of the compressive strength of both cylinder specimen. So you're going to crush both specimens. You're going to crush the first specimen. You calculate the compressive strength, and then you're going to crush the other cylinder specimen, and you're going to calculate the compressive strength, and you're going to divide. You're going to add both the concrete strength for the first and the concrete strength for the second. You add those together and you divide that by 2, and you record the average of both cylinder specimen. Note at the 7-day compressive strength, you should obtain at least 70% of the compressive strength. Yes, so you must have an idea of how much the compressive strength is going to be, or the ultimate compressive strength that you're looking for, the strength of your concrete. And when you do your first 7-day break, that equivalent must be at least 70%. So in the case of a 1-2-4 mix, and 1-2-4 mix, the compressive strength is 2,175 pounds per square inch, or 15 megapascal. So when you do the initial breakage of the first two specimens, that's supposed to be equivalent to 70% of 15 megapascal, or 70% of 2,175 pounds per square inch. In the event that you're not getting close to 70%, it does not mean that your concrete specimen has failed. You must wait until you do the 28 days compressive strength to know if the concrete specimen has failed or the concrete is too weak for your structure. So you're going to repeat the procedure for the 28 days compressive strength with the two remaining concrete specimen, right? And at this stage, you must obtain maximum or the required crushing strength at the 28 days for your concrete. So at the 28 days, that is the final setting time for your concrete specimen. And when you break your concrete cylinder specimen for that 28 days, you must get the required concrete strength. If your concrete does not meet that required crushing strength, you will have to remove and replace whatever concrete structure that concrete is used to pour. So I have seen firsthand on site here when I'm working on my bridge projects, we have used concrete to pour, for example, an abutment or a wing wall or a foundation, and it works out that the concrete failed the compressive strength, and what we have to do is to dig up that concrete and replace with new concrete. So that is very critical. The compressive strength of your concrete, it tells you if your concrete is strong enough to carry the load of your structure. So you must remember, to effectively carry the load of your structure is the strength of your concrete along with your reinforcing rebars. So that forms basically the structural integrity of your structure. So that is it for this presentation. And this presentation on concrete, we have would come to the conclusion. So this is the end of my video upload where concrete is concerned. As I've said to you before earlier, that concrete is a topic all by itself. So what I basically does is just to introduce a introductory phase of what goes into concrete mix design in terms of your aggregate, in terms of the different tests that you should do to carry out your concrete quality control and your concrete quality assurance. So in the event that you want to know more, you should read more. And as I've said to you, is a very important topic. So that is it for this video. And remember, if you have any question, to shoot me a question or a comment in the comment section. Remember to subscribe and remember to share the content. Thank you.